So here we have to solve this particular differential equation by using the method of variable separation. So first we'll have to do is we have to reduce it to a variable separable form. So to do that, we will assume that x plus y is equals to some variable v, and then we differentiate both sides with respect to x. So that will give us 1 plus dy over dx, which is equals to dv over dx. Isolating dy over dx, so we have dv over dx minus 1. So our original differential equation, let's call it number 1. So equation number 1 can be now rewritten as dv over dx minus 1 equals to v squared. So we have dv over dx equals to 1 plus v squared. Separating the differentials, we have dx equals to dv divided by 1 plus v squared. So now we have reduced the original differential equation to a variable separable form. So that means we can integrate both sides. Integration of dx is pretty straightforward, so that's x. And from the table of integrals, integration of dv over 1 plus v squared, so that will be tangent inverse of v. And let's take the constant of integration on the left hand side plus c. So that means if we take the tangent function on both sides, so we'll have v is equals to tangent of x plus c. And we finally replace v with x plus y. So we have x plus y equals to tangent of x plus c. And this is the required solution to a given differential equation.